Good afternoon, everybody. Thanks for coming. It's come to my attention that my title may have elicited a visceral reaction from some. Not entirely intentional, but I think it is useful to point out that there are a number of differing perspectives on the approach that one takes to integrating building information modeling into FM workflows. And so having been part of a practice of building FM solutions for the last 3 years in a very, very modern way, I think I have a unique perspective on this perhaps, and I'm looking forward to sharing that with you and also looking forward to your feedback. I mean, at the end of the day, all of you represent the end users. You have a lot more practical experience than I, and so this is also an opportunity for me to learn from you, so I look forward to your questions. A little bit about myself and why I should stand up here before we get started. I have been with Autodesk for now 16 years. I joined in a technical capacity 16 years ago. In 2001, I was involved with the team that did the technical due diligence for the acquisition of Revit Technology Corporation. We closed the integration or closed the purchase of Revit Technology Corporation on April 1st, 2002. So Revit's now been part of the Autodesk portfolio for 14 years. As part of that acquisition team and then the integration team thereafter, we were the group of folks who invented this term that we all use now to describe what we were trying to do, which is building information modeling. During this presentation, I'll define building information modeling from our perspective. I think there's a lot of different ways in which building information modeling is described, so it's good to have a shared point of view, at least for the purposes of this talk. And then I'd like to talk a little bit about what that means and how it can be useful within facilities management workflows. So I have a little bit of experience in this field. So as I said, we're going to start out by talking about what building information modeling is and the advantages that building information modeling can bring to FM practice, whether one is coming to it from the perspective of somebody who's just received a model, or whether one is thinking about how one might use models in ongoing operations for your facility. I think the most important thing, and the second area I'll talk about, which will result in a lot of questions back to all of you, is what you actually need. I think there's a huge difference from the perspective of somebody who works in technology between what people actually need and what they want. So I'll spend a little time talking about the difference between wants and needs. Right, so wants are based on aspiration. I mean, we were just treated to some insight into all of the amazing things coming down the pike in terms of capabilities in 3D. 3D as part of augmented reality through Pokemon Go on our phone. Opening our eyes to the possibilities of augmented reality at a price point that most of us can afford. But there's a lot of that in technology, a lot of what if or wouldn't it, or what if you could, or I might or may. I'd like to ground this discussion in the very pragmatic what we need, right? So what you need, what your field technicians need, what information should be at their fingertips when they go to complete a job, not what might be possible were they wearing a HoloLens headset and working in some other dimension. So we really want to ground this talk in the things that people need. And then I'll get into this question that I raised as a provocation in the title, which is, you know, what's wrong with as-built models as a basis for operations? And I'll show you some actually models from our customers that I think are really great representations of models built for design intent, for construction, or even representations of the as-built building. So I'll show examples from customers. The customers' names are on there as credits, and I'm actually showing them as examples of what to do for their purpose, but their purpose was not for operations. Their purpose was for other things. And that's important. Because at the end of the day, if you're focused on your needs, you don't want all of these other things that might be wants to get in the way of you executing against those needs. So I'll describe what that means in terms of as-built models. And then I'll look at a couple of different strategies. Strategies for taking a model that you receive as part of a capital construction project handover process and adapting that to your needs. And then the idea of what we do about all those other buildings. Right? What about all the buildings that don't have BIM data and how you might employ strategies for modeling those with the end in mind, the end being the focus on the things that your technicians need in the field. And then some closing thoughts. I'm going to talk for about 45 minutes, hopefully, so I'll leave time for questions, but if there are really pressing things that you just got to get out there, feel free to jump in and ask. I'll be happy to either take them or ask that we hold them to the end. Okay, before we start, any procedural questions? Everybody can see, everybody can hear me? Good. Okay. So I'm going to let you read this. I'm going to talk about what BIM means to me, and it weaves in and out of this formal definition. The first thing that I want to draw your attention to is, I think, the most compelling difference, and that which is interesting to me personally, and I think of value for all of you, and that is the nature of BIM as digital. Right? So as a digital representation of the built environment, a building information model is computable. That means you can do things to it. You can perform operations on it, and you can receive a result of that operation. That means you can ask it questions, right? So the idea that you have a digital representation of the building's relevant functional characteristics, and I think functional is another key word here, right? We're focused on how the building performs, right? Your responsibilities are for building performance. The aspects of the digital model that are most relevant are those related to functional performance. And the reason I think this is interesting and important is BIM is often conflated with 3D or three-dimensionality or model-based representation. And I think as a company that's engaged across the full spectrum of model-based design, from that for video games and film, to product design, including the design of buildings and infrastructure, it's very important to draw these distinctions, right? A model that's representationally the same as physical reality, but doesn't contain any information, is not something that represents the functional characteristics. Instead, it's about telling a story. And we're not talking about storytelling here, right? We're not talking about augmented or virtual reality. We're not talking about cinematography. We're not talking about special effects. I'm not going to be talking about materiality in terms of how things look or the way light plays off surfaces. These are all interesting topics in and of themselves, but our focus is on the information in building information modeling. And so one could take that to a logical conclusion and draw the conclusion that a BIM model is in fact just a bunch of data wrapped in an artifice or structure that allows us to see and understand it. Right? So the framework that allows us to understand the data is the three-dimensional representation. But the real value is in that information and the ability for people to collaborate, to ask questions, and to operate, ultimately, projects based upon that information. So I'll focus on the I in BIM. And I also want to focus on the outcome, which is really better understanding. So if what I show you doesn't help the people who will use these tools to better understand what they're being asked to do, to better perform their job, then we've not been successful. Another often misunderstanding that I want to sort of dispel right off the bat is there is no one BIM model. All right, so there's a quote here from one of our customers who at the end of a hospital project received 14 models. And it was his expectation that there was one truth. There is no one truth. All models represent something, usually the perspective of the person or people who made them. So for the architects, they might represent intent. For the structural engineer, it's structural design intent or structural performance intent. For the mechanical systems engineers, it's the intent of the systems for which they're responsible. It's design intent again in that case. For the contractor, it may be more about pre-construction planning and logistics, or it might be about clash detection. But each of the models they build comes with intent and is a representation of that intent. The models that you receive that are usually an assemblage of multiple models with various intents are often labeled as built, but they're really a representation of as intended as well, and that's just something to keep in mind, right? So there is no one model that travels through the life cycle, the design and construction life cycle, that ends up representing other than a collection of everybody's intent as they put together their various models. And that's just something to keep in mind. I can come back and clarify that later on. So let's talk about need. All right, so the way I ask about need when visiting with our customers is I ask them about their maintenance plans. I ask them to show me their maintenance plans. I asked to go out and ride in the truck with the maintenance guys. I asked them to see what they carry with them when they go on a job, what they take into the building, what they leave behind in the truck. If they've got digital information, I asked to see what they've referenced recently. Right? I asked them which equipment they're maintaining. Right? So what's on their upcoming list, their calendar of equipment that they've got to maintain in the next 30 days, 60 days, 90 days? What haven't they touched in more than a year? And then what they need to know about that equipment to do their job, right? So what are the pieces of information, the insights they need? Do they need to know static pressure? Do they need to know the horsepower of a motor? Do they need to know what the replacement parts are? Do they need to know when the warranty expires? Who the manufacturer, who the installer was? Is it someone they've worked with before? Is it somebody they can reach? These are what I would describe as being needs. These are relevant pieces of information associated with the piece of equipment that's represented in the model. And so the question I would ask all of you as you think about modeling and the use of module is the information in models information you need? Then how do we make the model represent what we need? So one thing about, this is just one way of thinking about this in just one slice through the problem. Right? There's categories of equipment. So think about all the different categories of equipment that you have and for which you're responsible. And then the frequency of maintenance. Anything you maintain more than once a year is a candidate for something you would want to have a representation of, right? For which there should be a representation. And then you think about what that representation should tell you. And I focus, as I said, I'm focused on the information, right? The information that's part of the model, the things you need to know to maintain that piece of equipment. And here are some examples of types of equipment that you might be maintaining on a frequent basis within a certain category. And then the actual things that are needed, right? Because all the data that's in the model may not be what's needed, right? There's going to be a lot of stuff in there that designers put in there because it helped them in thinking about what may be or equal later on, right? So there may be characteristics of that piece of equipment that you don't need to know about any later because they were superseded by the actual equipment that you purchased. Designers may have selected models from the internet, from manufacturers, as proxies for their intent that contain a lot of information that are really there to help convince somebody to buy that piece of equipment or to specify that piece of equipment. And a lot of that data is not useful. And then there's other data that's collected by the general contractor during construction. What I would indelicately describe as the cover your ass information, right? Stuff that they need to know. And a lot of this you'll see data collected in the field in the form of photographs to show that damaged equipment was in fact repaired. Videos to show that things were started up in the right sequence of operations so that should something break later, they're covered under warranty. Not all of that is necessarily going to be stuff that you're going to want to associate with your model for the purposes of ongoing operations. And then within that, there's going to be a set of categories of information that you want. And I mentioned some earlier. Horsepower on a motor, pressure on a valve. Those are the things you want. And what we've seen characteristically is that this number is somewhere between about 10 and 25 for a specific piece of equipment, depending on the nature of that piece of equipment and its complexity of operations, right? So if you see somebody with a model that's got hundreds of fields, you should be somewhat circumspect about whether or not you need all of those, and that may be an opportunity to streamline the experience later on. And so this really, the question to all of you is, and please, I'm actually interested in hearing from the perspective of this audience, what do you maintain? What are the top 5 things that you worry about that you've got a scheduled maintenance plan for? What are those things? Anyone? As far as equipment, yeah. Chillers, AHUs, pumps, boilers. Fire extinguishers, elevators, anything you're permitting? Generators? Anyone else? Okay, so is it safe to say, based upon limited number of contributions, that it's a fairly well circumscribed group of things, right? So we know what we maintain, right? Fairly short list, we know what it is. The people with whom we work know what those things are, right? So let's get to models and why the model that you're likely to get if you've just finished a capital construction project is not the one that you want to use for facilities management. And we'll look at this a couple of different ways. Right, so these are models by our customers. And as I said earlier, these are good models. They're great representations of models built for their purpose. And as you look at them, you can sort of divine what that purpose might be. So building has an insane amount of ductwork, right? So this has got to be a coordination nightmare if you're doing sheet metal or you're trying to get the fire protection system in between the sheet metal, or you have other considerations about how you service this. But not all of that information is necessarily useful to you. I didn't mention, nobody mentioned, annual inspections of their ducts or quarterly cleanings of their of the registers, right? We don't maintain that stuff. We replace it when it breaks, or we address it when we have an issue. So there's a lot of data that potentially is not of value. And from the perspective of how we use the model in maintenance, that stuff gets in the way, right? So it's great when we see these fantastic fly-throughs of buildings in real time. But if you slow down those visualizations frame by frame and you think of them not as a movie telling a story about the space, but actually registering what you're seeing. Most of the things you see in films you don't never register. And most of this you would never register. It wouldn't add any value. There's also architecturally focused models, and this model was actually built for construction, I believe. But again, there's just a lot of material here that may not be of value. It's a well-constructed model representing the major systems of the building. But it also has a lot of visual complexity. And I'll show you some models later on that are very, very different in their intent and execution. Another good model, fairly clean, fairly low level of detail in terms of the systems represented, but a bunch of stuff like furniture, which is probably not considered a managed asset. It is in some cases for some groups, but in most cases, it's just data that you're adding to the model that you may not derive value from. And I want to talk in a minute about why that's relevant from another perspective. Again, another model here, beautifully made model, well constructed, well thought out, provides great visualization reference. And what we're not suggesting is that you throw all of these away. These have value. They have value should you start another capital construction project, a renovation. They have value for even minor retrofits. They have value in many, many ways. They're just not particularly value for the purposes of helping your maintenance team out in the field execute their responsibilities. So, some of the things that we see, models that are very complex, models that are just huge, 50 gigabytes, full of images and versioning and equipment that you don't maintain, systems that nobody ever would look at again after they were installed, a bunch of non-managed equipment. And the reason this is a problem is that you inherit this model. The model is valuable as long as it represents your building. But if the model no longer represents your building because it's too expensive for you to maintain it, you're going to stop using that model. And it's going to be just like wherever you store that thumb drive with the data that you have on from the last project you did, right? It's going to age very rapidly. And so we have to think about how we maintain this data. And given the investment and the money we have, even with access to students, which was referenced this morning, it's much better to be on the conservative side and focus on the things that you can maintain and manage yourselves. So let's look at a couple of different strategies here. One for building up models and one for taking the ones that you're getting down. Now, before I do that, I want to talk about something called level of detail. And this is another sort of fun topic that we could turn into a headline that might generate clickbait. Level of detail has been defined, and I'll talk about a specific definition sort of to ground this. So this is a specific definition. This happens to come from the American Institute of Architects, but every architectural and engineering organization, as well as government organizations, have a definition at this point of level of detail if they're talking about building information modeling. And really, what it does is, and I've highlighted the one relevant thing so you don't have to read the whole thing here. It's really about defining characteristics of the model elements and the amount of detail associated with them. And then defining that at different levels of project development. An LOD runs typically, and I say typically because there's some disagreement about this, between 1 and 500. Some groups, and this image is from the BIM forum, have introduced a level 350 to sort of fine-tune this between 300 and 400. But what it really gets to is you start out, as one might imagine, at a highly conceptual level. a building is a box, a wall is a box. And gets down to the level of detail at 500, or in this case I think it's 400, where you're showing substrates and other aspects of the materiality and the construction of a specific assembly. And this applies equally to equipment, although this was the best sort of overall example that I could find. The interesting thing about this, though, and I think why this is relevant to this conversation, is level of detail is often applied in a very homogeneous way. So someone will say, well, you know, you're in operations, you need a LOD 500 model. Well, the LOD 500 model is like the one in the bottom right-hand corner, right? So first of all, I wanted to dispel the notion that there is such a thing as an LOD 500 model, right? If we go back to the definition, there's a level of detail of an element, right? So the definition itself, I drew your attention to the word element. So every element in the model should have a representative level of detail, and that level of detail should be related to the usefulness of the detail. Now, folks who are really good at this stuff, and I was once one of those a long time ago, love making these really detailed models because it's a demonstration, as Chris mentioned, of our expertise. We've overcome this hostile system. We've demonstrated mastery of it, and what better way to demonstrate mastery than to build really, really complex models. But the matter of fact is that we don't, for most operations, need that level of complexity. So let's think of, somebody mentioned pumps earlier. Think about how you maintain your pumps. And think about the representation of a pump, somewhere between a box and its fully representational as manufactured form with nuts and bolts and fasteners and labels and all the other things that are on that pump. Somewhere between that box and its reality is a sufficient representation once the data is hung off of it. And there's no need really for the whole model to have that same level of representation. And so, yeah, again, just to reinforce this point, right? So there's sort of this notion that comes with level of detail that it is linear, that it goes from conceptual to as fabricated, that some would say conceptual to as operated, but that it's really okay to have, and in fact encouraged to have varying levels of detail rather than uniform detail. So focus on the details in the areas that matter, and if the detail's more than you need, then we should talk about how we remove that detail. So, you know, you get a big model. We saw some examples earlier. What do you do to reduce the amount of information in that model? So, you know, without talking about a specific example, I just want to give you some ideas about some of the things that we might consider. All right, so the first thing you want to do is make a copy of it, right? Which you're going to do anyway because it's on a thumb drive. Or it's been uploaded to a cloud service from which you've retrieved it. Do you have a copy of the model? Revit models, at least specifically, and I'll talk to Revit specifically, although most systems work in similar ways, allows you to link a whole bunch of models together. What I'm suggesting is that you remove those links and you merge the necessary information into the model so that you have the greatest flexibility in cleaning it up. Right? This relieves you of some of the burden of knowledge of that system and its intricacy. That you remove unnecessary images that you're not going to use, that may have been there for the purposes of illustrating aspects of the design or construction or things that may not be relevant to you at this point. That you filter the model and find categories of information in which you're not interested. Right? So I'm not really interested in tracking individual light fixtures beyond knowing which are specified in each room and which bulbs I should use should I need to replace them. So I'll pull all the light fixtures out. I may not be interested in tracking IT equipment in the system, so I may pull out the projectors because I'm not going to track bulb replacement or lamp replacement in my CMMS. I might pull out the furniture. I'll certainly pull out entourage, plants, things that really aren't relevant. And then even within the systems, go down and find detail that I don't need. And again, just keep simplifying until you've got that list of equipment that you manage, the context that helps you understand that equipment, and the properties within that equipment that are relevant to your ongoing operations. And then save it. And so these are some examples of some of these steps in Revit. This is, again, a fairly simple model. And you'll see the models that I show you are fairly simple. Right? So from an architectural perspective, architecture is context. in operations, right? You're not responsible for maintaining or managing the architecture at a level of detail where it's necessary to see every brick, right? Even if you were to hire somebody to come in and repoint all the brick on the outside of the building, you would bid that job out on a per square footage basis. You wouldn't be bidding it out based upon detailed models of the bricks. They're not going to ask to see that. They can site observe that. And so I've stripped the architectural model in this case down to really a very, very basic geometry that gives me contextual awareness of where I am within the building and what I'm looking at. And then I've taken all of the categories that aren't relevant to ongoing operations and filtered those out. Looking at this then in a three-dimensional view, but sectioned again in Revit, you see I've left enough of the interior detail to create context, but stripped everything else out. I've left the mechanical system simply because knowing where they are, knowing where the VAV boxes are, knowing where shutoff valves are is relevant and useful, but a lot of the other information has been stripped out. And then when it comes down to models of the actual equipment, again, these have highly simplified representations of those pieces of equipment. Essentially, they're decorated boxes, just so that visually you can tell what's what. An air handling unit on the right, a chiller on the left. You've got the basic inputs and outputs. The points are places where people may need to locate valves, nothing else. All of the other information is attached in the form of details, either as properties or O&M manuals or photographs or videos or things of that nature, most of which is gathered during construction, not during the creation of the model. And then again, the focus is on relationships. So this is the electrical distribution system. I really want to know where they are and in what corner of the building they are and how they stack. All right, so this is all I really need to know to understand where those things are and how they function from the purposes of sending somebody out there to shut them down. And then I'm going to have a diagram that's going to show them each panel and what's on each circuit, right? That's what I need to give them to operate. And that's the way we would think about this in an analog world, right? If we were thinking about this as an analog problem, we'd be giving people the bare minimum because that's something we have to maintain and we understand the cost of maintaining that. The cost of maintaining the model is no different than the cost of maintaining your analog information, right? So keeping it to that which is most necessary is beneficial. So now I want to show you another example, right? So this is an example, and these are a courtesy of our friends at University of Western Michigan. These examples show what you do when you've got a whole campus, right? So you've got a whole campus, not just the new buildings that have recently been constructed. And you want to go out and build models. And in this case, I think they may have gone a little further than they needed to, but it's representationally accurate. Also has benefits for things like wayfinding and other uses on campus. But once you get into the details, you see they're really just they're boxes. They're decorated boxes. There's a very, very limited amount of detail, just sufficient so that you have context for understanding the things that you put in them. And then when you break that down, what you're really looking at then is just a space. So this is a mechanical room. If you were to model a mechanical room, what you really need to know is where the boundaries are, the floor, the ceiling, the walls, where you have obstructions, in this case structure. Right, so this is a sufficient model to represent a mechanical room. And then you go out and you get your context. Right? So we have photographs, which are a great reference. We have the website of the manufacturer, which we can identify for the in-place units based upon its labeling or our own personal knowledge. And then we can go out and grab a model, in this case, from the manufacturer that has a probably greater than sufficient level of detail, but costs us virtually nothing to implement in our model and comes with most of the property information that we're interested in attached. So in this case, going out and finding stuff is relatively easy. But sometimes that stuff's not available. So then you can build things like this, right? So these are, again, very simple boxes that show the most relevant pieces or characteristics of that piece of equipment that is elevated in this case. You know, where you've got protrusions from the case, how much clearance you have against the wall so you know whether you can get somebody in there, whether you need special equipment, whether you need a ladder when you come out to service it. And all of this can be taken either from field observation or from the existing documentation, whether it be CAD-based or just you know, prints in your print collection. And then, there's always observation and measurement, right? So if you can't find the piece of equipment online, you can certainly climb up on the roof, snap some pictures, and model a representation, probably again at a greater level of detail than is necessary. But really, it's about creating context for understanding the information within the building information model that you're associating or attaching. So, the key message there then that I think is important and what we were trying to elicit as we thought about this topic is focus on those things that are needed, right? Start with the equipment you already maintain. Start with the information that your field technicians need to know about that piece of equipment, and then represent a sufficient amount of context to make that understandable. So this again is that same space with all of the relevant equipment, none of the smaller details, none of the conduit, none of the connections that that they could trace on site, but just the main pieces of equipment and the relevant properties. Again, a relatively short list of properties that would be populated either in the model or in the CMMS system. So a couple of things I want to talk about in drawing to a close here. One which I thought about talking about up front, but I think we should talk about now, is why BIM. Right, so I think the case for BIM in capital construction has already been well made. And there were references made to that this morning by Dennis, right? And we could recap some of those, right? So there's savings in design because you can simulate the performance of systems before you build them, before you actually procure them. So there's an opportunity to fine-tune the overall building performance, right? So you make decisions as early as conceptual design about siting that save you energy in operations. You're able to simulate the movement of people through the building and the building's use, so you can understand whether or not you're building spaces that actually satisfy the program as it was written. And this is really the remarkable thing about simulation. You can size building elements, your HVAC system. You can size your structural system. You can try out alternate structural systems, all virtually, without incurring any costs. So modeling and design, I think, is well understood, and the cost-benefit well justified. I think we're seeing increasing evidence of the cost-benefit in construction. And some of the things that I mentioned earlier, I'll just recap, right? Clashes, right? And this happens all the time, even on the most sophisticated projects, where stairwell openings don't align with the steel that's brought to site. If you can catch those kind of misalignments that run through ducts before you actually have the guy out on site fabricating the ductwork, it's going to save you money. And then there's things like driving fabrication directly from the modeling construction, which can really provide huge saving, not only in terms of first cost, but in terms of logistics, your ability to deliver material to site in a fashion that allows you to build it effectively. Risk management. I mean, it goes on, right? There's a lot of benefits for BIM in capital construction. I think that they're well stated. So the idea of the role then of a model that was developed for capital construction purposes having additional value as an owner is really attractive, right? So if you've paid for something, actually the capital construction team paid for it, so it's not part of your OpEx budget, so it's not costing you any extra. It's really attractive to think that there's value in that in operations. And was mentioned earlier, if 75% or more in some cases of the building's life cycle costs are operations costs, then it's very attractive to think that if you can streamline those costs or reduce those costs by applying something for which you're not paying, that's a really good deal. And you can employ some of the strategies we've talked about to make that model-based data useful. But that doesn't really cover the other situations where you don't have this data. Now, it was mentioned also this morning by Dennis, something that we saw in our research when we started working on building operations and the product we call Building Ops, is that most owners are challenged not by having too much information, but by having too little. Right? The information that you do have is often inaccessible, and it's certainly inaccessible to those who would most value it. Right? So it's in a plan room somewhere, usually in a basement, in a file drawer that somebody once remembered was the third from the left on the bottom, sometimes maybe, unless somebody took that and didn't put it back, in which case it's in the kitchen, on top of the cabinets, on the right-hand side, I think. But Joe retired last year, and we don't know whether or not he'll call us back if we call him and leave him a message. we probably should have got him a nicer cake for his retirement party, right? So there's a whole bunch of insight and information that's leaving the building, or is just dispersed throughout the building or the campus because people don't record where they put things. And so there's an opportunity then to sort of think about how we collect and manage data more effectively. And so BIM plays a role in this, right? So several times the idea of going out and doing an assessment or a survey has been mentioned. And right, so if you're collecting data, you could collect data and enter it in a tabular fashion directly into a CMMS system. But there's advantage in creating that context for understanding that data, and that's perhaps the role of BIM in existing conditions, right? It creates a framework for understanding. We understand intuitively as people pictures better than words, and a lot of data is really represented well in the form of pictures when combined with the information that's necessary. So I think there's also a strong case to be made that if you're trying to go back and put in place more formal programs than you currently have, you're trying to further optimize your existing operations of your existing facilities, that there is value in creating BIM models for those facilities at the kind of rudimentary level that I've described here, right? It shouldn't be expensive, they should be easy to maintain, and they should have only the most critical data. But in that case, I think they have value. And I think this becomes more clear when we think about how that's used, right? So early on, one of the things I said was, let's focus on needs, not wants, right? I actually need this thing, right? Now, a few years ago, I would have found it hard to believe that I would need it and not just want it. And I have a tablet in my bag, and I have a computer here as well, and somehow I need all of them, which is really hard to believe, and a watch. Because a few years ago, I didn't need any of these things, right? I wanted all of them, but I didn't need any of them. But what they all do uniquely in their own way in certain contexts is they give me information that's useful, right? In the case of the watch, really useful about me and my physical well-being, right? Whether I'm moving enough, standing up frequently enough. In the case of my phone, you know, what I'm eating, whether I'm eating and sleeping well. The same can be applied in other contexts, right? So the phone enables us, and it's been interesting in developing a product for this market, and thinking about what form factors people really, really like. And the nice thing about this is, and I actually made the mistake of not having a pocket, there's one here, is you can do that with a phone. That's really hard to do with a tablet. It's even harder to do with a computer. But at the same time, it's amazing the amount of dense information you can put on one of these screens now. And so in this context, 3D becomes very interesting as a context for understanding information. This is a screenshot of Autodesk Building Ops. And this is just a typical asset record that happens to include a 3D representation. So if we think of a not atypical scenario of a technician who's just been assigned a scheduled maintenance task, I've got to go out and change the belt on something that requires a belt. So what do I need to know about that task, right? I need to know where it is. I need to know what tools I need to bring. I need to know if there are any exceptional circumstances. So far, you know, memory served me well, but I don't get the exceptional circumstances part. Did I need a ladder on this job last time or not? Typically, if a tech doesn't bring all the things they need, on average, it's between 30 and 45 minutes to go and get it. Same with parts and tools, right? So if you can save 30 to 45 minutes on just a percentage, let's say 10% of all your jobs, that's real time. And so having this information that includes context in the palm of your hand, in your pocket, or in the free hand while you're performing a routine maintenance task, can really be liberating. And with one of the customers that we've been working with, who have the foresight to track how long tasks were taking both before and after the implementation of the technology they're currently using, is fascinating. You know, times to do things going from 5 minutes to 5 seconds or 30 seconds, processes that used to take 40 minutes taking 10 minutes. Significant amount of time savings, greater productivity from the same workforce because we're able to empower them by putting information in their hand. And I think that context that BIM provides really makes that happen. The other thing, before I go on, the other obstacle is getting this data in, right? So, you know, we've heard a couple of references to moving data from BIM to CMMS systems. right? It's by far a preferred method of getting data into your CMMS system than manual entry, right? So one end of the spectrum is manual entry. The other end of the spectrum is moving it effortlessly through digital means from one system to another in a useful way. I would tend to err on the side of using the digital transfer, right? I think most people would. And so for places where you have that data, it really, it takes setting up a building from a month or multi-month long process to a minute to multi-minute long process in some cases. It really, especially when the models have been built with maintenance in mind. So, just some thoughts about models you either receive or models that you build. And you know, this was mentioned earlier, again by Dennis in the keynote this morning. You have an enormous amount of power as owners, as long as you're at the table at the beginning of a capital construction project with the capital construction team to say what you want. And through BIM execution plans, there are ways for you to define that in terms that, you know, architects and the general contractors you work with and the engineers you work with are more than happy to help you as long as you're clear about what those things are up front. But later on, of course, it's something for which they'd love you to pay them extra. So the earlier you come to the table, the earlier you can be very articulate about what your actual needs are and what the needs of your field technicians are, the more impact you can have at the lower cost. Essentially, you know, a lot of things that others would like to charge you for as additional services later on should essentially be free if you get to the table early enough, because of things people are doing anyway. You just want to make sure they're representing your needs. So have them model what you manage. Right? Make sure they're modeling what you manage. And then make sure that you manage what you model, right? Which is the flip side of the coin here, right? Don't model stuff just because you can, because you want to, because it looks kind of cool, because somebody in marketing thinks it'd be really neat if you had high resolution 3D imagery of the boiler room for some reason. All that stuff is great. It looks like it's great on your wall of your office months before the facility is actually complete. It's great stuff to show your family, but it doesn't really have a place in the model because it's going to cost you money to maintain it. So unless that's your hobby, you know, I would try to discourage over-modeling. And then lastly, you know, which is, you know, something one of my colleagues reminded me to say when we were talking before we came out, don't try and use your modeling tools for maintenance and asset management, right? So it would be really awful if I were to come and visit with any of you and find you trying to manage your building using Revit. And, you know, speaking as somebody who works for Autodesk and, you know, as a shareholder, I would do quite well from you all who are trying to use Revit to manage your buildings, because Revit's quite expensive. And all of our resellers and partners would be very happy because you'd probably have to buy a lot of services from them because it's quite complex. It's a complex undertaking modeling a building. Yes, it can be easier, but it is quite complex. So, you know, I want to make sure that everybody understands what I'm not advocating for is you all, you know, going and buying a seat of Revit and a workstation to run it, which is a much bigger laptop than mine, and trying to, you know, send your field techs out there with a copy of Revit on a laptop so they can look up the properties of a pump. But that data is really important. It's the data, it's the information within the building information model that you want. So with that, I'm going to stop talking and ask, are there any questions? Yeah, down in front. Down in front.
Excuse me. So, if I understood you correctly, I would guess that to build the building, the contractor will need, in many cases, LOD 400 or 500, where we don't need that. Are you seeing who's stripping the model down? Are you seeing the contractor do that per your defined specs up front, strip it down before they deliver it to you, or is the owner doing that more often than not?
I would say right now it's the latter. It's the owner, right? And I think part of that comes from this all being so new still, and not having known what to ask for, right? And I think that the biggest challenge right now, looking across the owners that I've seen, and it may not be true of everybody in this audience, but I don't see the maintenance teams coming to the table early enough, right? So we see the capital construction teams driving modeling for the reasons that I mentioned, but we don't see the maintenance teams participating in those discussions. It's sort of that, that they're brought at the 11th hour to be congratulated on this new thing they're getting, but no one's asked them what they want. And I think the opportunity is for the because the best models right now are being built by contractors, or they're the most complete, because that is where they get to the highest level of detail, where they have the greatest risk to manage, and there is an opportunity for them to provide you the information they want. And it's a combination of their field team as well as their field construction team, the folks who are actually out in the field gathering the warranty data, taking site photographs, collecting other things that aren't part of the model, and the conditioning of those models. And I see that as part of the handover process. But you have to specify.
Yeah, so depending on how well they construct the model, if they're not really good with their structure on it, stripping it down could be quite a burden.
Absolutely.
Oh yeah.
If it's not structured.
Yeah,
correctly.
yeah, absolutely. In the back.
To tag on to that, having been part of that strip it down process, even though it's a royal pain, get everything you can and you do it. Or somebody that's good with the models. I don't think you want somebody else stripping it down, even though it's going to take you some time to find out what's important and what's not important. It would be nice to have some interaction with the designers to learn this thing a little quicker, but I think being part of that strip down is an important task for the owners. And I hate it.
Can I offer a counter option?
Yeah.
When the design teams put together models, they'll have an architectural model, a mechanical model, even though they're not separate packages like they used to be. Now they're all in one package, but they're being done. Architects do architectural work, engineers do engineering work, that kind of thing. Very simple. You can create a facilities management model based on the requirements that the facilities team would develop and say, create that model. So you don't have to go all the way to the end and rip it apart to get to that facilities model. You can take the information that's being delivered at the end and push it back into that model. But somebody has to own that facilities model in the process. And it can be part owner, it could be part contractor, it could be part designer. Instead of going all the way to the end and then trying to find a way to destruct it.
Chuck, you.
Yeah, I'd love to get in here. So to that point, one of the most useful tools we're seeing owners develop is what's called a model development specification, where in each of you define the use cases of the model, and for each of the use cases you define the level of development for certain elements, both graphically and from an attribution standpoint, and those are separate. Right? You have to define those separately, what they're going to graphically look like and what they will contain for attribution, and then who the model element author is. So it is highly possible.
Primary, secondary.
Correct. It is highly possible that your facilities use model may have a much lower level of development at that use case, right, for what's ultimately turned over to you. Ohio State calls it the conformed design intent model, where they're really taking design intent level of graphics. But the point is that this is all designed in a model development specification up front. Now everyone knows what your ultimate goals and because you'll have a deliverable for 30%, 60%, 90, 100, fabrication, estimating, all of these. That's how you get everybody on the same page and avoid some of the challenges you had, Steve, when we talked about trying to strip a model back down, because it wasn't clearly defined what all of that was. So things can become dependent upon other things, and the thing that you want to get rid of is a dependency for something you want to keep, and you can get really ugly. But if you can define the model development spec, then the people creating the models ultimately know what those use cases are, and it makes the structuring of the models a much simpler process.
And that goes in your BIM execution plan.
Correct, and the comment was, and that goes in your BIM execution plan.
That?
Are there any guidelines that say, when we talked about 100 through 500, if we said we want to model it at 350, one, do I know what that really means? And do the architects really know what that means?
It's interesting. There's no shortage of guidelines, but they don't all agree with each other.
The BIM forum document, which is
Most
ACE
complete.
and AIA, is probably the most prolific of all of them. So that's the American, the contractors, ACE, sorry, I can't think what it is.
Oh, Associated General Contractors.
Associated-
But
sorry.
it's actually now the BIM form. It's separate from AGC.
Well, but the two have combined to create, so they've got two of the largest organizations combining into there, and there's a great document, you can Google it, it's, BIMforum.org,
.org.
and you can get a free download, and it has a very simple diagrammatic for a lot of the different things. This is what a 100 looks like, this is what a 200 looks like, and you as, sorry, I didn't know who said it. You can look at it and go, I think that's all I need. I like one of those. You know, oversimplifying, but that's kind of what it's trying to help do. And you get to a point where you are showing simplified models much better than an overly detailed, because you don't need overly detailed, and you're going to pay for something you don't need. Sorry, guys.
No, thanks.
So in the end there, you said you're not advocating for using Revit for your actual management, facilities management model. We've stripped it down. What are your thoughts as far as how we're actually delivering this and sharing it with our trades and even my director of operations? So he's completely turned off of the idea of him because he says, well, I can't deal with that. So how are we providing and delivering this information?
So I've not talked about that part, but I'm happy to briefly, right? So in the spirit of being sort of vendor neutral here, I'm not talking about the product that we built, but we have a very specific point of view on that, right? So I'm delivering that through a product we created called Building Ops on a mobile device that looks just like this one. So, you know, in my terms, what's valuable is having that model on my iPhone in a way that I don't need to understand anything about how to navigate in 3D or any of the complexities of navigating 3D. So I click to an asset record. I click on the asset record. I bring up a 3D view, which is automatically oriented to the piece of equipment I'm interested in. I can show it to anybody who knows how to use a mobile phone, and they could interact with that. We've also, in building our product Building Ops, focused on interactions that people know, right? So what we like to say is if your technicians already understand how to use Facebook, how to take photographs of their kids, how to send an email or a text message, they're most of the way to using our application, right? So we're really focused on very simple interactions that take advantage of the knowledge they have. And what's really been interesting is we found in most campuses with whom we've been working, there was an expectation that there was low penetration of sophisticated smartphones. Right? Not mobile devices, everybody's got a flip phone, but of sophisticated devices. And therefore there'd be low usage, and especially on the East Coast with unionized workforces, resistance to penetration because the field techs wouldn't want to use their own devices, especially at schools that had a bring your own device policy. And then we went to our data, right? So the great thing about web services, you actually get to see what's going on in real time. When you look at the data, and we see much higher penetration than the schools are aware of. Because once the techs realize there's an advantage to them, that they don't have to go back and collect that piece of paper, that they're not running around trying to get more done in a day than they're really comfortable doing. They'll pull out the mobile device, they'll bring up the schematics, they'll bring up the O&M manuals, and they'll start to manage their ticket and their workload on the device because it's a benefit to them. So I see this as being really about mobility. So ours is a mobile-first solution. We have a web interface as well for the manager, for the director or vice president who wants to get stats and reports. And again, it's built in such a way that it should be easy for them to use, right? I think complexity in this market is the enemy of success. And most of the legacy solutions that are out there have been built over 30 years and inherit an enormous amount of complexity from fields like oil and gas exploration or managing airports, which have very complex systems and operations needs. But those may not be true for the majority of buildings. So, we're really of the opinion that these things make a huge difference when it comes to putting information in the hands of people who need it. In the back.
Jason, my question is more focused on contractual obligations we want to throw upon. From an owner's perspective, who should the owner ask to deliver these models? Should it be the trade contractor or the designer to update the model such that it's the right level of detail, content, info for facilities managers?
I don't think I have a good answer for that question. I think it largely depends on relationships. Yeah. Right?
I'll toss one. So in every organization I try to represent, we ask the architectural team to provide a reconciled, we don't call it an as-built because architects are deathly afraid of the term as-built, a reconciled level 300 or 350 model, which means by their licensure and contract, they're required for every change order and RFI that goes through the organization that they're supposed to take that content and put it back into the design to verify that it's legitimate. So by that vehicle, we tell them, then you should be updating the model.
Correct.
So through the construction
Yeah.
process, they're required to do that. Now, granted, they will probably want to charge more,
Yes.
but again, the architect's fee relative to the contractor's fee is relatively small. Not just because I'm an architect saying this, but seriously, that's the only place it will get done the way that you want it to get done. And you're going to yield essentially a level 3, 350 model, again, depending on what your flavor that you like. And it's coming from the team that generated the initial model. The 400 and 500 stuff doesn't actually even go into the model. It goes in different places. You know, so that is so far the only way that we've been able to successfully achieve that process.
And so, Dennis, you're saying that owners should be open to the idea of spending more upfront into the fees for designers for getting a deliverable that we are talking about.
I would say open to it, because not every time do they come back and say, I want more,
Right.
ironically.
Yeah, I mean, I think that the one thing I would add to what Dennis said is the more specific you as owners can be about what you want, and the more detail you can give. And I'll give you an example of a non-university customer with whom we're working. They're actually building models themselves. They have a BIM team, and they're building models of all of the standardized components within their portfolio of buildings. And they're providing those to any construction team with whom they work. And so as long as that design and construction team, and it usually is the design and construction team, uses the things they're giving them, they're guaranteed a level of conformity that they need on the back end. And the reason they're doing that is not because they're happy spending more money on these new people who have this new job, but because it's saving them so much, because now they're stocking fewer parts. So they've got much more advantage purchasing power than they would have if they allowed each of the design teams to specify whatever they thought that was as equal. Right? So it's incredible the amount of efficiency they're driving through their supply chain by thinking about this as a procurement problem,
Right.
not, or a procurement opportunity, not as a we need 3 or 4 new people to build these representative models.
A really good example of Dennis's point around conforming the design intent model, Ohio State's documents, they actually have the term they call the conform design intent model. While I always give the caution of don't ever copy and paste from somebody else's documents because you don't understand the context in which they came to those conclusions. If you'd like to see some contract language that talks about it, there's a really good example of it with Ohio State. And it's all up on their website. Just search Ohio State, their Buckeye BIM, and you'll find their BIM page.
But I have a question. I'm at Ohio State, so I manage the project files. So when you say reconciled BIM model, because I asked for record drawings, not as-built. Because everyone around here keeps saying as-built. To me, as-built are the changes that occur during the construction. So the contractors send the as-built changes to the architect, who then creates the record drawing, and that's what I expect.
And so so the definition of record drawing is slightly different in the industry. That's why we created a new term saying reconcile, because that means
So
you have to get that back into the model.
this, what I call a record.
Because other people may say the record drawing for design was when I was done with design.
And that's not the way.
See, that's it. So you always have to be super precise in your terminology.
And I always say, well, I have a little guideline that we give all the AEs that,
Yeah,
and it says record, it does
means,
not say as-built.
record means what? You have to define it in your terms, because otherwise people go, well, the industry terms record as this.
It's work.
It is.
CMs and myself, and I'm constantly asking for resubmittals because they're not correct.
Yeah, and you'll never win the argument, well, my definition of record is different than yours.
We got a minute left.
And that's why we came up with a whole different term, so that it just didn't go down that road.
Last question in the back.
I would like a little discussion or commentary on the change management of all of this. I understand that when we get new buildings, we do have these nice Revit packages that come. But from a managing a university side, we have 120 plus capital projects every year. Some large, some small, some are, continuing services. But all of these projects would want to interact with this model at some level, whether they're changing out a fan belt, the whole compressor, the whole infrastructure. We're referring back to this model. My point with the change management, though, is if you have 120 reactions to this, if they're using that data, then that data is getting updated in the process. So who's putting all that data correctly back into the model and being consistent about it with different scales when architects and general contractors sometimes aren't involved in these smaller change projects that interact with this data?
I'm not going to answer that in a minute. I wish I could, because that means it was a very good answer. There exists, let's recognize that there exists a change management problem with models. Right? This is something that we as an industry have to overcome and have to make easier to manage. I think on the purely operations front, where you're changing belts or you're changing similar pieces of equipment, that can be very effectively managed on the CMMS side and should be. I think that the ability of CMMS systems to push data back into the model of record, right, the operations model of record is improving, and I think that makes a big difference. But I think for, what happens with larger projects is you can include in your contract language the provision to update these models, and that is happening today. I think where the real challenge is in the smaller projects, the ones with less than $5 million, because nobody's responsible for updating the documentation on those. And I think we have to be clear that somebody has to. Otherwise, entropy sets in, our models fall apart over time.
I would like to refer to that as the 99%. Those are in terms of projects, whether it's a small box or a big box, it's still a project and it has elements. So I think the efficiency needs to be in how can we consistently over time, decades, manage all this data that we're wanting to continually reference. So it's a sort of
So the airport in Denver is an example. So some of their concourses are in excess of 1 million square feet, and that's one building, right? One contiguous building. So it's not like you can divorce this piece from the building and that piece of the building. It's one building. So in a model concept, you're really looking at maintaining that building as a model. There's an architectural model, electrical model, all those kinds, but it's one building. So over time, you're going to have to get to the point where you're going to have a team staff. So right now the airport in Denver has 3 people, all making less than 70,000. Top guy's 70, and it's probably 30, maintaining that because the other rogue organization that ends up, mucking with existing conditions more than any other organization, it's your internal maintenance facilities guys. The midnight contracting crew that throws up a wall, tears out a toilet, doesn't tell anybody, and that was the same thing in Denver until they threw up a wall and realized that there was no longer any fire suppression in the room that they had now created, and all of a sudden there was a life safety issue and people got in trouble. Even though nobody died, but it raised an issue going, okay, you can't go rogue. So they even had to create a project management process for these small projects to make it happen. And it was simple enough to do. They just weren't motivated to do it before, and now they were. So you have to have a team that's going to help do it. Hell, you want to do it with AutoCAD drawings too, right? I mean, somebody should be maintaining, and nobody wants to spend the money to do that, but they spend the money in the dumb pad at the end of the day.
Okay, thank you, everyone.
Thank you.